Hi everyone, my name is Anvita Bansal and the problem that we are going to discuss today is another one from your SDE sheet, which is Kadane's algorithm. So let's have a look at the problem. So what you need to do in this problem is you are given an array of n integers. Find the contiguous sub-array containing at least one number which has the maximum sum and return its sum. Okay, so let's take this example 1, 2, 3 minus 2, 5. Let me write this one. Let's say you are given this array 1, 2, 3, 5. Okay, 1, 2, 3, minus 2, and 5. 1, 2, 3, minus 2, and 5. Okay, so what you need to find is you need to find the maximum sum array from this given. Let me check if you can see my screen properly. Hello everyone, those who have joined the class. Okay, moving back. Fine. So when you need to find an array like this, let's begin this. Your output is 9. So how did you get 9 in this one? See, the maximum subarray sum is 9. How? I'll tell you, since the array that you are given will consist of positive and negative elements. Now, what is a contiguous subarray? Contiguous subarray means the elements that you choose from the array should be continuous. If you, let's say, choose 1, 2, 3, what sum will it give you? It will give you sum of 6, right? If you choose sum 1, 2, 3, and then 5, you leave minus 2 in between. What sum you're going to get? You're going to get 11. So basically you're getting the sum of 11 from all these elements, but that is not what you need to return, because it is not contiguous. Contiguous means that the elements should be continuous subarray, right? So since in this case it is not continuous, so what are the possibilities? Yeah, are you going to find out one? Are you going to find out all possible subarrays? Is that one thing that you're going to do? So what will be your time complexity in that case? How will you find subarrays? Subarrays is nothing but the combination of, let me check why it is fading. There's some issue with the screen. Still fading, I guess. Just a second. This doesn't seem okay. Okay, let's start here. So what we were discussing was you're given an array like this. One, 2, 3, minus 2, and 5. Okay, this is 1, 2, 3, minus 2, and 5. So what we were discussing is that we want to get a set of continuous elements so that you find an sub array with the maximum sum, right? Max sum. So one thing that I was discussing is, are you going to go ahead and find all the sub arrays separately? That is, sub array could be of 1 length also, of 2 length also, of 3 length also. So whatever 1 length sub arrays you're going to get, this is 1, 2, 3, that is going to take lots of operations, right? So what can we do here? What can we do? Let's think of it something like this. Can we store the sum of all these elements? You remember cumulative sum? Cumulative sum, right? Just there is one trick while we will be calculating this cumulative sum, and actually you will be good to go with the Kadane's algorithm. What do I mean by cumulative sum? See, what is the sum of values at index 0? This is index 0, this is index 1, this is 2, this is 3, this is 4. When I'm at this index, this is index 0, and let me check if you can see my screen by that time. Okay. So what is the sum that you will get till index 1? When I mean by cumulative sum, what I'm calculating is whichever index you are present at that point in time. So it should, let's say you are at index I, so that index I of this array should hold the value of basically sum of all the elements of all elements starting from index 0 to index I. That is what it should ideally store. So if you are in index 1, what is the value at index 0? That is 1. And what is the value at index 1? That is 2. So you're going to add these two elements. So let's add and write the result here, that is 3. When you are at second index, what should be the value? That should be the sum of all the three elements, that is 1 plus 2 plus 3, right? So it should ideally be 6. Do you see something that our dependency is on the previous index? If you are calculating for this index, let's say in this array, in this cumulative sum array, see some array, then you can just directly move to your previous index and check what is the value present and add the current value from the given array, and you will get the cumulative sum, right? Because each index here holds the cumulative sum of the elements from the given array. Let's say this is nums, from nums array, whatever the sum of the elements from 0 to that index will be stored in the this cumulative sum array. So if you just simply add I minus 1th sum with the ith index element in the nums array, you will get the cumulative sum of that element. Okay. Now what should be the cumulative sum at this position? So ideally it should be 6 minus 2, 4. But see, again, our question is to find max sum sub array. Max sum sub array. In order to find max sum sub array, if I just simply keep on doing sum of all the elements till that index, that is cumulative sum, and keep track of the maximum sum by that time, I'm not going to get my answer, because see, this is going to also store the negative index values. So when I come across minus 2, what is my sum going to be? Okay, it is going to be 4. That's okay, I'll store it. When I'm at 5, what is the sum? Add 4 and 5, that will be 9. Means the sum till index 4 is stored here, sum till index 3 is stored here. Now let's say I extend, let me make some other test case to make you understand. Let's say if my array looked something like this. If it was something like this, now what I have is minus let's do it minus 20, then what I have is 40, then I have is minus 5. Okay, so now in this case, when you are at this index, coming across index 5, 6, 7, now when you are at fifth index, you check, and if you were to calculate the cumulative sum now, 9 minus 20, right? It will be, right? Is that right? Okay. So now in this case, what is going to happen? You see that your cumulative sum has become negative. So you were calculating cumulative sum, it was increasing. See, it was 1, let's say this is 1, this was 1, then this was 3, then it became 6, then it became 4. Okay, it took a little dip and came, let's say, at this position, this is 4. Then it came back to 9, means it came above, and it was 9. Then it came down to minus 11. This is the cumulative sum that you are calculating. and you will see that you want the maximum sum sub array. So what would be the set of elements that you would want so that you get the maximum sum sub array? If you check for this part, that is 9 minus 4, that is means this part of elements will give you sum as 5. If you check for these, this is going to give you 6 minus, means if you include also 5 plus 1, it will become 6, 6 minus 1, it will become 5. So basically you need to find that sub array which has the maximum sum. So do you see one thing? Whenever, now if I calculate now minus 11, my cumulative sum has dipped to minus 11. Now if I'm at this index, even if I add 40, let's say it's not 40, it's 4, it's not 40, it's 4. Now if I add 4 to it, what will it become? It will still be negative, right? So let's say I add 4 to it, now it's minus 7. Minus 7, then again you add this value, let's say at this point in time, it's not 5, it's, let's make it, let me change the value. Let me change the value and make it. So what was it here? Let's make it 15. Okay, this is plus 15. Okay, so now what are you going to get? No, I think let's make it 1 only then. This is minus 20. What was this? It was 4. And let's keep it till here. Let it be. You'll understand here only. So my purpose of explaining why I use this array and what I want to explain is, see, as soon as your cumulative sum becomes negative, now you are adding some, even though you are adding some positive value, you don't know how large is that positive value. Is it large enough to make it positive? Even if it is, what you want to do is, just remove this. What you want to do is, whenever you encounter that your cumulative sum has become negative, you do not want to include that value, because just think it like this. You are cumulative sum is basically you are doing sum of all the elements of that index. If there is some negative value, we can include negative values also, but if there is some negative value such that which makes your cumulative sum itself negative, that means that value is highly negative value, right? So that your cumulative sum, which was the total sum of the elements so far, which was positive only, and that itself has become negative, that means this entire value which that element is holding is highly negative. So if you're at the point where your cumulative sum becomes negative, even if you add positive elements now, you have you don't want to include that element into your answer or in your sub array. So if I do not want to include it, I can make the sum 0. Let's say that whenever you encounter that your cumulative sum has gone less than 0, make your c sum as 0. Okay, and now start your iteration, resume your iteration with cumulative sum as 0 now. So if it was 0 and this value is 4, now 0 plus 4 will become 4. Now from this index, from this array cumulative sum, what is the maximum cumulative sum that you have found? So if you go and check at every index, 9 is the maximum that you have found so far. So 9, if you have found this at index 4, this was 0, 1, 2, 3, 4. If at index 4 you find a value that is 9, it means that it is the sum from 0 till that position. So the maximum sub array that you can find here is from 0 to 4, right? So if you check here, 1 2 3 1 2 3, so 6 6 5 11 minus 2 9. So we are getting sum of 9 using this sub array. What now you will say, why you are taking this negative value? It is anyway reducing your sum, but we want a continuous sub array. If I do not include it, so I have two options. What are those two options? Either I take its left part or I take its right part. If I don't want to include this, because I want continuous, if I take left part only, the sum that I'm going to get is 6, and 6 is still less than 9. If I include the right part only, so and only this one element, then you are going to get 5, which is not the sum which is greater than 9. Okay, let's say that you have excluded -2. Let's check if we can get some sub array from this part of your array. So 5, then next is -20. Again, -20 is, if you say so that we don't want to include negative values, that's what I'm trying to contradict. Don't think it this way that we don't have to include negative values. That is not the case. We can include negative values provided it makes our cumulative sum as the maximum till the index you are calculating it for. You're getting my point. If I am at -20, let's say I do not include it, I have two options. I take its left part of array or I take its right part of array. So if I take right part, I have only 4 as the element which I can include in my sum. So 4 would be the only element contributing to the maximum sub array. If I take the left part of it, I will have all these elements that can contribute to the maximum sum of sub array, and this value itself is 9. Okay, so you can visualize it in this way also. Whenever you encounter a negative value, you have two options: take its left part of subarray or take its right part of subarray. But for that, you also need to have some answers stored, which task can be done by cumulative sum subarray. I hope this is clear. So if I were to write the pseudocode, what it will look like. So your pseudocode would look something like this. You are iterating over entire array for int I starting from 0 less than length of your array and I plus plus, right? You are taking some, let's say, cumulative sum starting with 0, and then you want to store the maximum from the cumulative sum. So max also you take 0. So you start your iteration, you do, let's take your cumulative sum, C sum, I am taking C sum plus equal to your ARR of given array, and that index element we are adding to a cumulative sum. Then first thing is that we are checking basically. So what do we want to do? You have the elements of array. You calculate the sum, right? And then you check. You basically check if it is the maximum so far. Then what do you do? Max equals to math dot max of the sum that you have calculated so far and the maximum that was already present in your max variable. Now if then you also check, now you max stores the maximum current cumulative sum so far. Also you check whenever if your cumulative sum is less than 0, if your C sum is less than 0, you don't want your cumulative sum to go negative. So you continue your iteration with cumulative sum as 0 now. I hope this is clear to you all. So what have we done? And then after this iteration, you just want to return your max. Okay, this is your pseudocode. Now I'll do one dry run and help you understand this. 1, 5 minus 4, 9 minus 2, 6. Let's say this is our, okay. So initially what you took was you took your cumulative sum as your C sum was 0, your max was 0. Okay, you start your iteration from here. Your cumulative sum becomes 1. Okay, then you check your cumulative sum becomes 1. You in your max you check which is greater, C sum or max. So your max was 0 and your C sum is 1, so your max will also become 1 now. Okay, then your C sum is less than 0. No, it is 1. So you move to the next iteration, that is at this index. What is C sum? It is add the element to the given C sum. C sum was 1. 1 plus 5 will become 6. So this value is 6 now. Okay, so now you make it, let's not erase it, let's make it 6. This is 6 now. So again you do the check, and maximum will also be stored with 6 in this case. Then you come at this position. 6 minus 4 is 2, right? So C sum will become 2. Your max will store the maximum of C sum and max. So max is currently 6 and C sum is 2. So will max be upgraded to 2? No, max will stay 6. That till now we have got 6 as a max answer, so it will let it be 6 only. Okay, then I go to the next value, that is 9. CSUM will become 9 plus 2, 11, right? And your max will be compared, and since max was 6 and which is smaller, so it will be upgraded to 11 now, which means the values from here till here is our max so far. This is giving us the maximum sum subarray so far. Now I'm at this index, and this check, we are always checking this condition also, but since cumulative sum is till positive only, so we don't make it 0. Now your next value is minus 2, so C sum will be reduced by 2, that will become 9, and max will still store your 11. Now you are at this index, 9 plus 6 will be 15, and your cumulative sum will become 15. So basically the entire array in itself is coming out to be maximum sum subarray. I hope this is clear to you all. So let's go and code. Okay, int C sum current sum 0, int max 0, right? For int I0, I less than n, right? And then I plus plus. First you calculate C sum plus equal to ARR of I, and then you upgrade your max equal to math dot max of max value and the C sum that you calculate, right? Then you check if C sum is less than 0, then you make your C sum as 0, and then you do the iterations, and then you return max. Let's check. I think it will give error because it is expecting long. So let's return it long. What is the issue? Okay, I am initializing max with 0, but what if the entire array consists of negative elements? So let's make it integer dot min value. Okay. I should have submitted. So this is done. If you have any doubt, you can ask in the chat. Okay, so whatever doubts you have, Aryan, regarding the previous lecture, I suggest we can take this up somewhere else, but not in this video. Or if you try to go through the video once again, you'll get your answer. Okay, and any more doubts you can ask me. There's one good problem, not actually. Let me show you. So in this SDE sheet, when you go, this Kadane's algorithm, you go to view, okay? And then if you go to this problem, save your life. This is a very nice problem, an application of Kadane's algorithm, which we just discussed. So you all can also try this particular question and try not to take any extra space. And it is based on exactly what we did. You want to see, I'll explain you this problem also. You want to calculate the maximum sum substring. Okay, same as the previous one. Find a substring which is sum of ASCII values of its every character as maximum. So I hope you all know this for a fact. I'll I hope you have understood this. I'll just go to the whiteboard and help you understand. So what I want to discuss is, like, you calculated maximum sum sub array, you want to calculate maximum sum substring. So you have A, B, D, C, E, F, let's say, whatsoever. And you will be given one extra array which tells you, see, every character in a string is associated with certain ASCII values. Okay, 67, 68, and 69, and so on. So whatever the ASCII values are, based on that, if you try to do, you want to calculate some sum, int sum, and you do a plus b, right? Although a and b are part of the string and these are characters, or if you run a loop like this for int I0 and I goes to length of your string I plus plus, and what you are doing is you are calculating some sum is equals to sum plus equal to str dot char at I. So what do you think it will return you? And I ask you to return me sum. Bear with the handwriting because I just want you to understand the concept. So now you must be thinking how two characters are getting added. So characters are associated with their ASCII values, 67, 68, and so on. So whenever you do something, you try to do calculations, mathematical operations on the characters individually, their ASCII values, since sum is of type int, so the int, whatever integer value is associated with that character, that will go into the sum. So basically sum will be calculating 67 plus 68 and something like this, 1.5. Okay, so this is what is happening when you try to iterate over the string like this. Now the question is that you want to calculate the maximum sum sub array. Now you will be saying that all the characters are positive only, the ASCII value. If you go and check this ASCII table, I'll just show you also. So if you go and check ASCII, so you can check that each character is associated with ASCII values, and I'm sure you must be aware of it, but you can see it here also. So small characters have different ASCII values, and bigger, the caps characters have different ASCII values. Like you see 65, this is 65. I was writing small a 65. So this is associated with 97, this is associated with 98. So when you are doing a plus b, basically these two values are getting added. Okay, coming back to this problem. Now you will say that A, B, C, D, none of them is negative. You will never find a negative ASCII value. So why shouldn't we return the entire length of entire string itself? The thing is that there is a catch, that they are giving you an extra array which stores their special customized ASCII values for certain characters. Let's say X stores BS and B stores minus 145. So what it is saying, that when you are iterating over this string, the value of B that your calculation should take should be minus 100 and not this value. What is the actual ASCII value? It is 98, right? So they are saying don't take 98, take minus 100. And whenever you come across S in your string, don't take the actual ASCII value of S, which is 115. Take 45 as your ASCII value. So obviously this is going to make some difference. It is as same as if D was some positive value, B was some positive value, now B will be minus 100. So you just visualize it as an array of ASCII values with these customizations, and from that, how will you find the maximum sum sub array? Another catch in this question is that you want to return the indices, the start index and the end index. Okay, if let's say you are finding substring this as the maximum sum of ASCII values, which starts from D, B, F, B, S. I think this is the entire string itself. In this case, you are finding this as the substring with the maximum sum of ASCII values. So you want to return that string itself. So for that, what you can do is you can manage the indices. Let's say some start index, start IDX, and some end IDX. Okay, and then with the indexes, when you will come across after all the calculations, if you will have indexes, you can also find the substring. So first thing is that how do you calculate the cumulative sum? Okay, right? Second thing is, again, the pseudocode that I wrote for Kadane's algorithm, same is going to be written here. The only difference is here you have just imagine an array with the ASCII values of these characters and also with those customizations which you are given. So it's a good level question. If you want, I can discuss it from start till end along with code in the next lecture. Although tomorrow is scheduled for this problem, I'll show you. Tomorrow you are scheduled for, so I just wanted you to show this problem. I wanted to discuss this only, but since for in Geeks for Geeks they scheduled Kadane's algorithm only, and when you click on Kadane's algorithm solve, you come across this problem that we discussed. Although I wanted you to solve save this view problem. So I'm giving you as of now as a homework. Tomorrow when you come back, in the beginning only write in the chat if you want me to discuss save your life problem. I'll start with this and then we'll go to the next problem. Okay, and the next problem for tomorrow will be this subarray with given sum. Actually it is similar, so we can, this is this almost similar problem, so we can discuss save your life problem tomorrow. So I hope today's lecture is clear, and that's all for today. Thank you everyone, let's wind it up. Bye bye.